Hello again, everyone. We are going to get started on some practice problems. I'm going to do practice problem number 1 from Module 6, and that is when 2.13 moles of C3H8 burn in excess oxygen, how many moles of CO2 will be formed? Assume this is complete combustion. So, we're dealing with stoichiometry. We are dealing with going from moles of one substance to moles of another substance. And recognize here we don't have to go from grams to moles to grams as we will in some other problems. So this is a little bit easier. The first thing we need to do though is we need a chemical equation to work with so that we can see how many moles of C3H8 produce how many moles of CO2. So let's go ahead and try to form a chemical reaction here. We're given this is, okay, your C3H8 burning in excess oxygen. We're assuming this is complete combustion, so it's pretty obvious here this is a combustion reaction. So what we know with combustion reactions is there is some starting chemical. In this example, it's C3H8. And in combustion reactions, we're combining with O2, oxygen, and we're going to get CO2, and we're also going to get water vapor, so just H2O. So now writing our equation is pretty easy. Now we just need to balance it. So we have 1C on the right side and 3 on the left, so that's definitely unbalanced. I'll go ahead and change that right now to be 3 CO2, so now our carbons match. Let's check out our H's. We have 8 on this side, 2 on this side, so I'll go ahead and put a 4 here. Now let's check on everything else. So our C's are matching up, our H's are matching up. The only thing that may not is our O's. So we have 6 O's plus 4 O's, and that will give us 10. So we should have a 5 there. And this is our fully balanced chemical equation for the combustion. And the reason why they said assume this is complete combustion is because we know we can have incomplete combustion sometimes. That would produce carbon monoxide, or CO. So knowing that we're producing CO2 really helps us to know what our equation is. So now we have an equation to work with. All we got to do is go from 2.3 moles of C3H8 and go to moles of CO2. So we do this by doing just a regular old conversion. We're going to do C3H8. I should say mole. Let me just erase some of that there. Write the number, that's kind of important. Moles of C3H8. And we put that over 1, and we're going to multiply this. We know in order to cancel out, we're going to need moles C3H8 on the bottom. That way it'll cancel out. All we need really is the comparison between C3H8 and CO2. And we see in this chemical equation, it's a 1:3 ratio. So the 1 is our moles of C3H8. And then we have a 3 over here for CO2. 3 moles CO2. So if we go ahead and plug that into a calculator, 2.13 times 3, we'll go ahead and get 6.39 moles CO2. And as far as significant figures go, this is the only number that really counted because these are exact numbers. They're whole numbers. We don't need to worry about those. So we have 3 significant figures. We multiplied so we can stick with 3 significant figures there. And that's our answer.